Hello, everyone. Oh,
And then you can adjust your actual volume with the black dial on the right side of your earphones. Can everyone hear me? We're all okay? Are we good to go? Okay. Great. Apologize about that.
okay. So this is probably going to be my normal volume the whole time. And I'll try not to go down to this kind of volume and make you turn up the volume. Then it go really loud. I'll try to be consistent. Sorry. But before we actually get started, looks like still adjusting. Okay. Before we actually get started, I have a really important question that I gotta ask. That's totally unrelated to the topic. How many of you have been to the Azores? How was the food? Yeah, really good. Okay. Okay. So that's an internal discussion we've been having. One of our team members thinks the Azores food is terrible. So anyway, this session is called AI Anytime, Anywhere, getting started with LLMs on your laptop or whatever your computer is today. Come on in. There's plenty of seats in the front row, just a few left. Okay, so I'm going to start with another question, which is how many here are using some sort of AI service today? That's pretty well, yeah, that's what most people. Cool. And then how many of you are using some sort of local AI option? Now, by local, I mean not using ChatGPT or Claude or even Copilot. How many of you? Cool. Okay. And then how many of you are using Ollama? Okay, we got one of the maintainers, and so he's using Ollama. That's great. That would be scary if you didn't raise his hand. Well, I'm one of the maintainers of a project called Ollama.ai, and so I'm excited to share with you a little bit of background with LLMs, but also get into how to use Ollama and what kind of things you can do with Ollama. So AI, I'll just start with a few slides at the beginning. AI is not a new thing. It's been around for a long time. It's been computer science research into artificial intelligence for decades and decades. You know, probably 20 or 30 years after things really got started, I took a course when I was in college, Introduction to Artificial Intelligence Programming. And that was 32 years ago. Things have progressed a lot since then, and the AI that I learned in school is nothing like what we're seeing today. But as with any long road that we are on, any long road that we take, well, where are we on this road? Are we at the beginning? Are we at the end? Is AGI tomorrow? Or is it, are we just at the beginning and it's going to be another 100 years, 200 years before we see something that's really the AGI ideal? But as with any long road that we take, sometimes a big rock falls in front of us. There's a big obstacle, and we have to adjust what we're doing to adjust to the new landscape. And one of the problems that people are using these AI solutions, and they're asking and they're trusting without verification. Yeah, it's mind-boggling to me that people are just going to maybe a ChatGPT, asking a question, they get back an answer, and they go, okay, that must be true, and just go with it. And there are problems when you do this. One of the classic examples is that lawyer a few months ago that asked ChatGPT for, he's going into a court case and wants to generate some document that he hands off to the judge and to the other party. And he uses ChatGPT to create this document. And looks really impressive. He's like, wow, that looks great. That's better than what I could do. Hands it off to the judge and to the other side, and they look at it and like, whoa, these guys have a really great case. And they start clicking on the links for the previous cases, and none of them exist. So there are problems with when we trust just like, as a developer, you never trust the input you're given. You always got to verify what you're seeing. And there are other tools that are integrating with these online services. I use a note-taking tool called Obsidian, which I think is great. And there are Well, when I originally started looking into this presentation, there were like 6 or 7 plugins that use ChatGPT. And I looked this morning, and there were 22 plugins that use ChatGPT. And they're submitting all your notes up onto ChatGPT or to other OpenAI APIs to index and to tokenize. And then they're asking questions against that data that's hosted, well, that is now, they're using ChatGPT to answer those questions. And maybe that's a good thing, because personal data means more personalized results. So this is awesome, right? Not always, because sometimes you submit some information to ChatGPT and it becomes part of the model. Maybe it comes out of the model right away or a little bit later. And so there was an example with Samsung. And what happened at Samsung, this is back in April or May, a couple of engineers were involved, and one of them didn't attend a meeting, or maybe he did, but there was some notes that were generated from that meeting. And he just took the whole set of notes, didn't really want to read all the notes, submitted it to ChatGPT, and said, summarize this. And it did. It came up with this great summary. But on OpenAI's website, scroll down, do some searches, you'll eventually find a link to a Google form that allows you to opt out of sharing your data with the model to make the model better. And these guys hadn't done that. And so they had a meeting about this internal project. And sometime later, a journalist calls Samsung and says, hey, can you comment on project XYZ? It's like, well, how do you know about that project? You shouldn't know. I just asked ChatGPT. And so now Samsung has a policy of no one uses ChatGPT. And I've heard this from other companies where they don't allow access to ChatGPT in general, or you have to use their special hosted version that's on their Azure. But some other researchers saw this and thought, well, if good results are making it into the model, what if we have some fun with it and put in some bad information? What happens then? And yeah, they've seen that bad information can go in and skew those results for future requests. And then I love this. This is from Midjourney's licensing, or its terms of service. And you scroll down, it's a long legal document. You scroll down, it says, if you're not a paid member, you don't own the assets you create. Instead, Midjourney grants you a license to the assets under the Creative Commons Non-Commercial Attribution International License. So if you're creating an icon and you use it for your business, and you used it for free, you got some issues. I guess you have to get caught, but then you got some issues. So there are lots of these problems, and so lots of companies are generating policies around who can use these online services, because we don't know who owns the IP, the answers that come out, or we don't know if we even have legal rights to those answers. And so maybe not the entire solution, but a solution for a lot of these problems is perhaps going local. And so thankfully, the tool that a lot of the tool runners use is called Llama CPP. And Mr. Gerganov from Bulgaria was nice enough to give us a code sample of here's how you might run it if you wanted to host your own model. And it's only 1,300 lines of kind of intense C++ code, so easy afternoon read. And so you could implement it too. But there's other ways to do this, and there are easier ways to work with this. But first, I have some definitions that I want to cover. And I might as well tell you a little bit about myself. So, I'm Matt Williams. I'm one of the maintainers of a project called Ollama.ai. We're a team of 7 people, where about 5 of us are at the booth. So a large portion of us are at the booth, which is just out there. So after this session, not now, after this session, you can go over and ask them some more information. I see some familiar faces, so I've seen a lot of you at our booth, which is awesome. If you have any questions afterwards and we don't get a chance to ask them or answer them right here, then you can reach me on all the socials where I'm Techno Evangelist. The one place I'm not techno-evangelist is on Ollama.ai. We'll talk about the idea of being able to push models, but I have a bunch of models on Ollama.ai/MattW. So the one place I'm not techno-evangelist. So let's talk about some terms. Large language model, LLM. What is that thing? So the whole goal of a large language model is basically to predict the next word. If a word gets plopped down, based on the context, based on the prompt that was asked, and the word that's there, what's the most likely next word? And then based on that word, those two words, and then the context, what's the most likely next word? And so it keeps building out all those words until it ends up with the final sentence. Yeah. So it just builds out everything as we go. So it doesn't, when it writes down that first word, it doesn't know necessarily what that last word is going to be or how long it's going to be. It just kind of figures out, just like we do as we start saying, at least for me, I have no idea where I'm going to end up with a sentence until I get there. Although I knew roughly what I'd say for this presentation. So that's generally what an LLM does. LLMs are made up of lots of pieces, and one of the main pieces that goes into an LLM is a token. Now, a token is kind of like a word or a word part. It's really the most common words and parts of words that are around. So you're all sitting on chairs. A chair, well, the word chair is probably going to be a token all on its own. Table would be probably a token on its own. But podium, I'm at a podium, maybe that might not be a word, or that might not be a token. Maybe it would be pod and eum as two different tokens. And hippopotamus might be, I don't know why I chose hippopotamus, but 3 or 4 tokens that go into that word. So it tries to find those most common word parts and turns those into tokens. And tokens don't get stored as, chair. It's not CHAIR that gets stored in the LLM. It is a token. It is a number, a numeric value that gets associated with that word. And every time that word shows up in the stuff that gets trained on, we're just storing that token or referring to that token. And then there are weights and biases. So the weights and biases, so in the model, there's all these tokens that are in there. And all these tokens are linked to each other by a weight. And the weight just says how related are these two word parts or tokens. And it's not just on a single dimension, it is thousands of dimensions. So there's all these links between all these different words or different tokens. Initially, when we first build out the model, all those weights, they're all the same. But gradually, we start to train the model. And training adjusts those weights so that some of the dimensions, they're really close to each other, and in other dimensions, they're really far apart from each other. But those are that's basically how the model figures out, goes through all the nodes, goes through all the different layers, and figures out, based on those weights, how close those words are together, based on the context, what is the most likely next word. Now you add up all the weights and biases, and you get parameters. And so when we talk about a 7 billion parameter model or a 70 billion parameter model, that parameters, those are the weights that connect the different nodes together inside the LLM. And so quantization comes along. This is a big word, big complicated topic, but at a high level, those weights are stored as 32-bit floating point numbers. And I said those weights, you add them all up together, that's how many parameters there are. So 70 billion 32-bit floating point numbers, that adds up to a lot of data. I mean, even just 7 billion. So 7 billion, the 32-bit is 4 bytes. It roughly adds up to about 28 gigabytes of storage just for the 7 billion parameter model. 70 billion, add another 0 to that. So this is huge file sizes, but quantization takes those 32-bit floating point numbers and basically puts all the weights into different buckets and into groups of weights, and then puts each of those weights, say, in a box. And let's say at the bottom of this box we've got set up a bin for each of the our quantization amount. So Usually the models are quantized often to 4-bit quantization. And the 4-bit quantization means that it's 4 bits. That's 4 bits is up to 16, 0 to 16. And so at the bottom of our box, we have a bin for 16, I guess it would be 17 bins that the values can go into. And so if we've got maybe all of our values are between -1 and +1, maybe the first bin is -1 to -0.8, and the next bin is 0.8 to 0.6, and the next bin is 0.6 to I don't know, 0.42 or something like that, all across that bottom of that bin. And all the weights just kind of fall into the right bins at the bottom of the box. And that way, the first bin, well, that's bin 0. And that's the value that we store for that weight, rather than this long 32-bit floating point number, we just store a 0 or a 1 or a 2. And it turns out, when you do this, and when you're actually doing inference, going down to the 16-bit numbers or 4-bit numbers still works really well. And it's shocking that even sometimes down to the 2-bit quantization, it's shockingly good for how small you can get these models. Then there's another thing with quantization called k-means. And the idea of k-means is sometimes when you put all those weights into a box and you drop them into those different bins, sometimes there's a lot of weights towards one end and a lot of weights towards the other end, and the middle is kind of empty. And so with the k-means, we're basically figuring out what are the clusters of weights, and just creating a more precise bin for some of the ones at this end, more precise ones for the ones at this end, and skipping all the numbers in the middle. And so we can be a lot more precise, but that requires also storing kind of a map so that the system can figure out, well, what does this quantization value actually mean? So that's a little bit of how that works. That's probably the most one of the more complicated topics in all of this. And before Ollama, we would go to a site like Hugging Face to download our models. And here's a screenshot from Hugging Face. And I don't see the quantized. If we actually clicked on here, we'd see the different quantized versions. But we definitely see 7 billion, 70 billion, 70 billion, 13 billion. So we see the parameters listed in the file name. And if we clicked into any one of these, we'd see the Q, what quantization number it is. And so at this point, I want to get into a demo. And I forgot to pull out my little demo script to ensure I cover all my stuff. So let's go over to, let's make sure I've got Ollama. I'm quit Ollama. And I'm just going to, oh, okay, I will figure that out in a second. Let's cancel out of here. Okay. I'm just going to make sure I've deleted Ollama, because that makes things more fun. Okay, so I've just wiped out Ollama, and I've already actually downloaded Ollama, because I don't want to do a download right here, because internet, Wi-Fi, conferences, not so good. But I've already downloaded it, so all I do is run Ollama, and as soon as we run it, it's going to say, hey, no, good. Hey, do you want to move this to the applications directly? Yes, I do. And when we do that, it's going to pop up a box that says, hey, welcome to Ollama. Click on next. Install the command line. Yes, I do. And I'm just going to type in my password. And now I can run my first model. Now, the installation process is a little bit different if I were on Linux. And so on here, we have a simple script that you can run. So you can go to the Ollama website, click on download, and then here's the script that you would run on Windows, or sorry, on Linux. And it's the same thing if you were on WSL on Windows. Okay, let's get rid of that thing. Okay, so I've downloaded Ollama, and now I want to run it. Let's create a new. Let's create a new. There we go. Where's my terminal? Hi, term. Come on. Where'd you go? Okay, it's not there. Not anywhere. Nice. This is always an awesome part of the demo where my terminal doesn't even pop up. Well, let's use this thing. Oh, that's weird. Okay, we'll use this one over on here on the side, and we'll bump up and bump that up. Okay, so I want to do, let's clear the screen, Ollama run, and I'll use Llama 2. You can see at the end of this string, I've got some tags that say I want to use some model other than the default. I'm just going to stick with the default. And now I can run my prompts. Why is the sky blue? And it thinks about that for a second and then spits out an answer of why is the sky blue? And that time that it's taking, sometimes it's just loading up the model, or that sometimes just takes a bit of time. So why is the sky blue? Okay, here's why it is blue. But we also keep the context, just like if you were using ChatGPT, we keep the context here so I can say, is it ever green? And it knows I'm talking about the sky because I mentioned that in the previous question. So we keep that conversation. So I just used Llama 2. Llama 2 is one of many models you can install. And so if you come to Ollama.ai and click on this models link, let's bump up the resolution a bit. Here are all the models that we have on our library today. And so you can see Llama 2 Uncensored, Code Llama, Code Up, da-da-da-da-da. We've got a lot of models. SQL Coder, Star Coder, Vicuna, Wizard, a bunch of wizards. And if we come back up to Mistral was one that was added, a week ago. So that was pretty exciting. And yeah, so we got a lot of different models. In fact, we can also allow you to push your own models up as well. But if I go into, oh, that's annoying. If I go in here and I do Ollama pull Llama 2, we already have it downloaded, but you're going to see something that might look a little familiar if you use Docker. Each one of these lines here is basically another layer within the model. And so we have this idea of a model file, which I'll show you in a second. And the model file you define much like a Docker file. And then we store the actual contents in a series of layers, and you're downloading those layers. And so if one model shares a layer with a different model, you won't have to download that layer again. Let's see. Now, I've actually got a lot of models on my laptop because I'm trying everything, which is good that I have a disk that has 4 terabytes, because I would run out of disk space every day. Because if I run Ollama list, you'll see, well, a lot of models that are mine, but also a lot of the library models, including lots of versions of Llama 2. So there's all the models that I've got on my machine, but let's try making a model file. So I'm going to go into Visual Studio. I'll maximize this. And so here is a simple model file. And this might look kind of familiar. It looks kind of like, a little bit like a Docker file. So right at the top, I've got from Llama 2. So this is from a model that I am pulling out of the library. Now, if you have downloaded a model from Hugging Face and it's already quantized and you want to use that, you can say, instead of from Llama 2, from where is it on your disk, so that the model file or the Ollama can find it. So you could use those as well. And then sometimes these models use parameters. And so in this case, I'm setting the temperature parameter to 1. And then there is a template that's associated with Llama 2. I am inheriting that template because I'm not overriding it. If I include a template in here, I would overwrite that parent. And here I've got system. You're an experienced product manager at a tiny software company, only speaks English. When you respond to anyone, only offer a single open question rather than a list of needs. And so if I try, let's go to this prompt. Let's clear that. Let's clear that. Okay, so if I do, if I want to create this model, all I have to do, because I've got the model file and I'm in this directory, no I'm not. Let's go into this directory. I can just do Ollama, create, and I've called this XPM. I've actually done this before, but I can do it again. And it reads the model file, figures out if there's any layers that need to be created. I've already created this, so it knows that all of this stuff already exists. So I use these already existing layers. And now I can do Ollama run EXPM. And I want to build a tool to track water intake, because I need to drink some more water. Interesting. What kind of insights are you hoping to gain? So I just said every time the person asks a question, answer back with one other question. So you kind of keep building, keep providing more and more information, and maybe help you think a little bit about what you're doing. Let's go on to another, a little bit more complicated example, 5 whys. So sometimes, one of those questions or one of those tools that you can use to figure out why something is happening is ask a question and then somebody asks, well, why? And you ask another, you answer it, and by 5 whys, you've probably really understood why something is happening. But if I just do a simple model file that's from Llama 2, set a temperature, set a stop word, which just says, if you see this value, stop. And then I've got, when you receive a prompt, you'll ask why the user thinks what they said. Goal is to probe for more information. After 5 rounds of questions and answers, you'll summarize the entire conversation. And so if I try that, D, let's go into 002, and I'll do Ollama create 5 whys. So again, it creates that model file. It already sees that most of them are, oh, there was one layer that's new. So it's created that model. But if I do Ollama run, hard to do this on this podium. Ollama run 5 whys, and I give it that I want to build a tool to track water intake. Great. Can you tell me more about what do you want to do? And so if I do, I want to do that. Okay, great. Ugh. So that's 3, 4, and 5. That should be the last one, but it keeps asking me more questions. So this isn't really working. I'm gonna have to do something else to get this. The model doesn't really, this particular prompt doesn't understand that, well, there are 5 questions and I need to do something at this point. So I need to write some code to do this. So I've written this simple application using TypeScript. I'm also using a module that I've created. So I'm on npm.js today called Ollama-node. And so I'm using that. So I'm creating a new Ollama object. Well, before I get to that, let me go over to the API, the actual API. So if I go to GitHub, this is our full GitHub repo for this project. Everything is there. You can download the whole thing. You can see how we actually build stuff. In documentation, we've got an API document. And in that API document, we talk about all the RESTful endpoints that are installed on your machine as soon as you install Ollama. You see there's a client and a server, and that server is serving out these endpoints. And so there's an endpoint just for generated completion. You do a post to /API/generate on localhost /11434. Anybody see the relevance of 11434? No? Llama, right. So if you go with a 4 being an A and a 3 being an M, then it's Llama, which is kind of goofy. But anyway, so go to port 11434 /API/generate, pass it a body of the model is Llama 2. In this case, we're specifying 7B. And then the prompt is, why is the sky blue? And it's going to start streaming back a response to you. And then we've got some other ones for creating a model, listing models, showing model information. And actually, one of our maintainers, who's sitting right in the middle here, also wrote a Python binding to make this easier to work with if you're a Python developer. And so you can look at that code there. I'm more of a Node.js kind of guy and TypeScript, so that's why I'm using this. So I've created my own library that's kind of based on his, but I first created an object called Ollama, and I'm just setting the model to be my 5 whys model that I created just a few seconds ago. And then I'm taking in some input from a read line. What's your idea? And then it's going to start streaming out the answer. And then I'm actually having it printing out each word as it goes along. And it's going to repeat that 5 total questions. And at the end of the 5th question, I'm going to send it a new prompt, which is, you've reached the end of the 5 whys, summarize all the information so far. And it's going to print all the words as it spits out. And so if I go to, where am I? I'm in, let's go in here, cool. And then TS node 5 whys. What's your idea? What was my idea? I want to create a water intake tracker. Oh, that's not how you spell tracker, but anyway. Okay, water intake tracker, it spelled it correctly, that's good. Can you tell me more why you want to create this? Awesome. Great, you want to, okay, so I can keep answering the question. So that's 2, this is 3, 4, 5. Okay, and then it does the summary of all the information I collected. So that's just an interesting, simple example of how I might use Ollama in some code without needing anything else. It's all just purely Ollama. So let's go on to section 3. If you wanted to use Python, if you want to see what else is here, anything else interesting? No, there's nothing interesting there. So if you want to see how you'd use Patrick's Python binding, it's pretty simple as well. We're just importing the client.py file, and then import client, and then client.generate llama 2. Why is the sky blue? So again, super simple to use from Python. There's a lot more you can do from here. And in fact, there's a demo in the repo. If you go to examples, there are a couple of examples using LangChain. So LangChain built an integration for Ollama a few weeks back, and they've provided some documentation and some examples. Actually, I'm not sure if they wrote this one or I wrote this one, but here is an example of how you'd use LangChain to bring in a document. This is pulling in a PDF document, embedding it, generating all the tokens, and storing it in a Chroma DB. So this morning at the keynote, they used Neo4j as a vector database. In this example, we're using Chroma DB as a vector database. So there's a lot of vector databases out there. And then once I've got that all in Chroma, then I'm going to ask a question. I'm going to do a search inside of Chroma to pull out the relevant stuff from that PDF document, submit that as input to my model, and be able to ask questions to that model. So it's definitely a lot more complicated than the previous examples I showed, but you could then expand this out to do all sorts of really neat things. And you can take a look at our examples on our repo, also on the LangChain document on the LangChain website. Let's go into one other example that I think is definitely just a fun one for me. And it's my mentors example. So a while back, I was thinking, well, it'd be really cool if I could create some mentors. Different people I could ask a question to and say, I'm thinking about this idea. What do you think? And it would respond from different people. Could we do that? Could we load different models that allow me to ask different people and almost have a conversation with all 3 people? And so I'm going to ask your help for me to come up with an idea. I need an animal, and don't say llama. I need any animal. Not a llama or alpaca. Buffalo. Excellent. I need an action verb. What? Dance? Okay. Buffalo and dance. I need a thing. Any like object, something you'd hold. Party hat. Okay, so we want to create a business that generates party hats for dancing buffaloes. So we're going to do that. I'm going to use tribe, and I want to build I want to make party hats for buffaloes when they dance. Very common. This is going to make us millions, I'm sure of it. Thank you for the idea. And let's see what comes out. Let's make this bigger. Looks like Neil deGrasse Tyson is going to come in first for an answer. And so we got his answer, which is great. And you can read that if you want. But he answers in the context of astrophysics. And then Gary Vee comes along and sees that question from the previous Tyson and says, okay, well, here's my input. I'm going to continue this conversation. And sometimes they refer to each other. And now Owen Wilson, another great mentor of mine, can come in and go, whoa, or whatever he's going to say. And sometimes it's not perfect. So let's try that one more time, because that's kind of fun sometimes. I want to make party hats for buffaloes when they dance. Catherine Janeway from the Enterprise is going to answer. And she's maybe a little bit in the future, but she's going to answer what she thinks about buffaloes and party hats. And then Martha Stewart, that's awesome. And oh, man, I never see this error, and I've seen it twice now in this demo. Let's do it one more time, because I'm a glutton for punishment. How are we doing on time? 8 minutes, okay. Oh, Donald Trump's going to answer. I'm scared of what I'm going to see. Buffaloes aren't exactly known for their dancing skills, but hey, if that's what you want to do, who are we to judge? Anyway, so we see how different people, oh, he's going to make America great again. And then we move on to Catherine Janeway, and again, we're seeing that error. Interesting, I'll have to figure out what's going on there. I know exactly what's going on there. It's something stupid I've done. So that's my mentors. How are we doing? We're doing, 7 minutes. Let's see what else I can do. Oh, another cool thing. You're all sticking around. This is awesome. This is great. I guess you're all stuck. Maybe there's some Velcro on your seats. Yeah, no, we're all good. So let's see, what else can we do? We can do, I mentioned Obsidian. So here I've got, this is Obsidian that I'm really low resolution. Let's bump that up. And I just put in some, I just grabbed some text from a few different websites. And I created a simple plugin. This was an example that I did for a blog post that I did about a week ago about how would I incorporate Obsidian, or how would I incorporate Ollama into Obsidian? What could I do? And so I just created a simple summarize plugin that will create flashcards, because that's one of the things I often use Obsidian for. I will generate flashcards, I put them inside Obsidian, and then I have an integration with Anki, which is a SRS or space repetition tool, to then show me flashcards. Well, that's the thing I keep meaning to do, because I think it would be really, really great. I just never get around to it, because creating those flashcards is always a pain. And so I created this thing that creates flashcards, except it doesn't always work. We'll see if it does right now. So hopefully this is going to go through all this text, bring it in, summarize it. Ideally, if I were smart, I would bring it all in and store it somewhere, which I'm not doing. But here it is. Here's my flashcards. What's the name of the tech company that's being sued by U.S. Justice Department for antitrust? Google. Hey, that worked pretty well. Okay, so that's good. And then I can do maybe another example of summarize. I think summarize is actually broken, but outline this document. And it brings that in, and it comes up with a nice outline of this document. Again, I should have saved it, but okay. So here's the bulleted points of the document, which is awesome. And I've got my talk for DockerCon that I could do that same summarization or that same outline. So these are different examples. I'm going to, actually all the code for this I've got in that blog post from, I think it was about a week or two ago, on Ollama.ai. So if you go to Ollama.ai, let's go to that. Let's go to, let's just go to Ollama.ai. And I go to a blog. There is leveraging LLMs for your Obsidian notes. We've got a bunch of other things. We put out that blog post today about the Docker image. So I mentioned that you can install for Linux and for Mac. We also have a Docker image, official Docker image. So it's Docker run Ollama/Ollama, and that's available. So I think that's about all I wanted to cover. Hopefully you got something out of this, got some cool examples, got some fun stuff. And if you have any questions, you can answer them or ask them in 4 minutes and 44 seconds. Come up to the microphones and you can ask them. I will hear you on my speaker, on my headphones.
Do we have any questions?
Don't all rush up at once. Okay, yeah, please.
Yeah, so like, what is the footprint of like running Ollama on your laptop, and like if we are thinking of deploying it in production on Linux, so what is the kind of scaling we need to run these things?
So how much memory is required? How much, what are the resources required? So really, Ollama itself requires very little, but it's just the models that they require all the space, and it depends on the size of the model that you're using. A 7 billion parameter model, we generally say you need at least 8 gigs of memory, 8 gigs of either unified memory on the Mac or memory on a Linux box, and we're going to try to push as much of that into the video memory as possible. But really, the LLM model itself takes up maybe 3.5 gigs, but there's the operating system that also has to run. We need the OS in there as well, and so that needs some overhead as well. So that's why we say 8 gigs for the 7 billion parameter. I think 13 billion we say either 16 or 32, and the 34 billion parameter, I know we definitely say 32 gigs, and the 70 billion parameter we definitely say 64 gigs. So it's roughly, these are all rough, super rough numbers because every model is a little bit different. Every quantization is a little bit different. Was there another part to that question? What's that? CPU power, yeah. So on, the other part of the question was, what's the CPU that you need? So if you don't have a GPU, you better have a really fast CPU because it's going to be better on GPU. The kind of, there's 2 parts to answering a question or answering a prompt in Ollama. There's the first part where we just try to process the prompt itself and figure out what's in the prompt, tokenize that prompt, and that's CPU bound. And so even if you have the most amazing GPU, it's still going to use purely the CPU. But it's pretty fast. And then the actual, generating the answer, that's all GPU. And so if you don't have a GPU, well, it's going to be slower. But it's better with a GPU, and the bigger the better, newer the better. It's hard to say. I mean, I have a 2-year-old M1 Max with 64 gigs of memory, and a 7 billion parameter model. I'm getting 60 tokens per second, which is a really good response. Your experience may vary. Yeah. Anything else? Anyone else? 1 minute and 41 seconds. Rush, rush, rush.
Thank you. I saw you can alter the process a little bit. Do you think of making Ollama talk to each other?
Ollama talk?
Yes.
Yeah.
Oh, actually, it's not like the talk. It's like the models communicate, which is.
Okay. So getting the models, can we get the models to talk to each other? And so that's kind of what I was trying to do with that mentors example. And sometimes you actually see one conversation bleed into the next conversation. But it's not something that Ollama does. I mean, it's not something that we have built into the product, but it's something that you would build in whatever code that you write. So take either the answer that comes back. We also provide a context, which is basically the answer and the previous all the previous questions, all already tokenized, and you can hand that to the next prompt, to the next model. But it's something that you need to manage as a developer. Yep. 30 seconds. 27. No more questions. Come on. Somebody's got to. Oh, it looks like rush. 20 seconds.
So in your prompt, in your Docker file, your model file that you were building,
Yep.
you could give it a single prompt as to what it is. Can you give it multiple prompts so that if I have different use cases for a single model, or do I need a separate model for each one?
Yeah. So the question. Well, yes, everybody heard the question. Can you have multiple prompts and have the, depending on the question that comes in, go to one of those different prompts? And no, you have one system prompt and one system prompt per model. But that said, if you're building a tool, you're using TypeScript or Python to build, or any language, to build some application, it would be up to you to process that question coming in. And then maybe you always send it to Llama 2, but in the code, you can give it a new system prompt based on what kind of question was asked. And so you can change these things at runtime. Ideally, you have it in the model file, but you can change these things at runtime in the code, whatever code you're writing. Okay, looks like I'm over time. So if you have any other questions, we've got a booth right outside. It's like just past the lightning talks area, so right on that wall. Come and visit us and ask us any questions. Thanks so much.
Thank you, Matt.